Hello everyone, welcome back to this channel. So today we are going to study about NumPy array in Python. Now before diving deep, tell me one thing. There was already so many built-in data types in Python. Then why NumPy array? Okay, now understand. Python was always a very easy, simple, having lucid syntax. So it was always kind of popular. But there was a problem with Python. Like while we studied the data types in Python, we saw that data types contained heterogeneous data. And secondly, they always contain the address instead of that value directly. So because of these two reasons, Python was very slow. Now the NumPy array solved this problem. How? First of all, it contains homogeneous data, only the numerical values, no other values. Like you cannot store string or other types of data. That increased its speed. Secondly, it directly stores the value, not the address. So the execution speed was increased. Okay, so beforehand, Python was simple, easy, popular, but a problem, that is the problem with the speed. Now NumPy array came and it has solved that problem also. That's why NumPy array is so popular in data science world. Okay, now let's understand what are the things we can do using NumPy array. See first to use that array, you have to import the package. So I have import numpy as np means np is just a nickname. You can give anything. It's like conventional that we give np. Okay. Now I have to run this one. Then the numpy package is imported. Now this one is like creating a numpy array. The syntax is np. You can write numpy also. We don't want to write that big name. That's why we have used np. Now np dot array, in the bracket you have to write the number you want to give. This is like d type float. I have given float. If you give nothing, then let me show you first. If I run this one, then an array of 1 2 3 will be created. Fine. This is what is known as numpy array. Okay, now suppose I want to create some float data types, so I can write d type equals to float. Then this will be float 1.2.3. Fine. So this is the way you can create any numpy array. Next, by using the arange function, np.arange 1 to 15. That means 1, 2, 3, 4, 5, 6. The numbers will be generated. Now I have written, just let me show it first. What will happen? An array will be created from 1 to 14. The last one is excluded. Now suppose if I reshape it with 2 comma 7, then what will happen? Let me show you. 2 means 2 rows. 1 row, 2 row. 7 means 7 column. See 1, 2, 3, 4, 5, 6, 7. So what has become? It has become 2 rows, 7 column. You can write something else like suppose 3, 5. Then what will happen? See, the problem is that now we have 14 values, but we are trying to give it a shape of 3 comma 5. 3 into 5 means 15, but here we have 14 values. That's why it is showing us as an error. So what we can do? We can write like 7 comma 2, 7 into 2, 14. Then we will have 7 rows, 2 columns. We have to reshape it as in a way that it contains 14 number. Okay, now suppose I write 16. Then I have 15 numbers. So now I can save. Now if I try this one, this will show an error. Because I have 15 numbers. So it cannot save it in 7 2. But if I write 3 comma 5, then it will be 15 number. We can write 1 comma 15 like factors. Okay, simple. Reshape means reshaping the array. That's what we need to learn. Next one is, suppose I want to take all those numbers starting from 0 to 10, but there is a gap of 2. Then this will become 0, 2, 4, 6, 8, 10. Okay, every alternative number. You can do 3, then what will become? 0, 3, 6, 9. Okay, so it is just creating a range but with a step value. Simple. Like list, we have studied these things in list also. Next one is linspace function. That this one will be linearly spaced. Like suppose 0 to 1. I want to give 5. That means within 0 to 1, it will give me 5 values having linearly spaced. Let me show you. See, there is a gap of 0.25, 0.25, 0.25, 0.25. So you can see there are 5 numbers having linear gap, that is here 0.25. So if you want these types of array, you can write linspace function. Fine. Now suppose I want to create an array which will contain all 1. Now we can write np.ones. Ones function means it will give us the values where all the values are 1. So suppose I write 3 comma 5. Anything. So what will happen? 3 rows, 5 columns. First one is rows, second one is column. 1 means it will give us value 1. Similarly, why I want all of them to be zeros. So instead of ones, I have to write zeros. Here you can provide anything. Okay. Next one is random.random. That means I don't want to give any value. You select any random value. See here, 3 comma 4, 3 rows, 4 columns, any random value. You run it many times, the values will change. See, notice any value, the values will change. Okay, because it is generating some random numbers. Next one we will study dimensions of an array. Dimensions of an array means here you can see that the array is two dimensional. 1D array, 1D array. This is in another array. So this is a two-dimensional array. Now let me show you. See, this is showing that this is a two-dimensional array. What is 3? This is the column. 1, 2, 3. So there are 3 columns. The array is like that. Let me show you. It is like 1, 2, 3, like this. Here we have 4, 5, 6. Okay. You can see this is an array. Okay. So shape is 2 comma 3. 2 rows, 3 columns. Clear? Now how can I reshape it? By using the reshape function. If you reshape, then it will be simply reshaped. Like if you use reshape function, it will be reshaped into 3 rows, 2 columns. See, 3 rows, 2 columns. 1 column, 2 column. 1 row, 2 row, 3 row. 3 rows. Fine. Now suppose I have an array of 1, 2, 3, 4, another array of 5, 6. And I want to concatenate them axis wise. Let me show you how it happens. First, I have 1, 1, 2, 3, 4. 1, 2, 3, 4. See, I have this array. I can show you 1, 2, 3, 4. Next one is 5, 6. Next one is 5, comma 6. Fine. Now what I want to concatenate them. But how? I want to concatenate them row wise. That means I want the output to become 1, 2, 3, 4, 5, 6. So it will become like this. So we have to write np.concatenate function array1 comma array2 comma axis equals to 0. 0 means it will concatenate row wise. Let me show you. Clear? 1, 2, 3, 4, 5, 6. Okay. Concatenate function you have to use and you have to pass axis equals to 0. That's all. Now suppose I want to add in a different way. Like I want to add 1, 2, 3, 4 and I want them to be added like this 5, 6. Now tell me how can I do this? I am adding them column wise. How can I do this? To do this, first I have to change its shape to this way like 5, 6. This is known as transpose of a matrix. When the matrix is transposed, rows become columns, columns become rows. So I have to first transpose the matrix. Okay, now check how I will be doing this. So first I have to transpose this. Now this matrix is transposed. So it has become like this. Now I have this one and I have this one. Now if I add them, concatenate them and I write axis equals to 1. Because 0 means it will be added row wise, 1 means it will be added column wise. Now this will be concatenated into this one. This one. Now let me show you. Clear? So you can concatenate in two ways, row wise or column wise. Fine, no issues. Now suppose I want to split the array. First I have created an array where I have taken 10 numbers. Now I just want them to be splitted. Like I want in the first row to hold 1, 2, 3, then 4, 5, 6, then 7, 8, 9, 10. This way I want to split. Now see here what I have done. I have split it after 3. So what will happen? After 1, 2, 3, it will be splitted. See, this is the first subarray. Next, 7. 7 means after 4, 5, 6, 7 is printed, now it will go into the next line. 9 means after 9 is printed, it will go to the next subarray. So 8, 9 is printed, now it will go to the next subarray. Fine. So it will, you can split the array by giving any particular number. Then the number up to that number will be printed, and then the next line will start. The next subarray will start. Okay. Now tell me one thing. Why 1, 2, 3, 4? How we have achieved this? You remember the enumerate function? We made a complete video on enumerate function. It just adds the index value. So for I comma subarray in enumerate, that means with every subarray, I will be added. The index position will be added. Okay. Now see here, I have given I plus 1 because I want the index position to start from the 1. Otherwise, it will start from the 0. Fine. Now see this one. Element wise operations. I have first created an array 1, 2, 3. Second array is 4, 5, 6. Now what I want to add them like 1 plus 4 to become 5, 2 plus 5 to become 7, 3 plus 6 to become 9. Then what we can do? We can just write the add function. Then this one will be added. Every element of the arrays will be added with each other. Let me show you first. See here 5, 7, 9. Fine. Now suppose I want to add all these numbers. I want 1 plus 2 plus 3. Then I will use the sum function. Sum of a, that means 1 plus 2, 3, 3 plus 3, 6. See the output? Sum of array a equal to a 6. Fine. Now we can apply statistics also, like if I want the mean, then v dot mean will give us the mean value of the array. 4 plus 5, 4 plus 5, 9, 9 plus 6, 15. 15 divided by 3 equals to 5. See, 5.0. Now what is the minimum of A? Minimum value of A, 1. Maximum of B, 6. Okay. So these are simple operations we can do using NumPy array. Now see next one. Dot product of two arrays. Here 1, 2, 3, 4, 5, 6. Do you know how to do the dot products? Let me show you. First 1, 2, 3. Next one is 4, 5, 6. Now the rules is that first tell me the shape. 1 into 3. 1 row, 3 column. What is the shape? 1 row, 3 column. Now, do you think that multiplication is possible? No, because the rule is that this number and the starting number will be same. So, this one will not be possible. So, what we can do? We can transpose this matrix to this form. 4, 5, 6. Now, what is the shape? Now, the shape is 3 into 1. 3 into 1. Now, see the ending value 3, starting value 3, both are same. So, multiplication is possible. Clear? Now, how to do the multiplication? 1, 2, 3. Fine. Next, 4, 5, 6. Okay. Now, the rule of multiplication, if you don't know, concentrate here because it is kind of important and confusing for some people. If you don't understand, then only. So, you have to follow these rules. It will go in this way and it will go downwards. Fine. So, I will take the first value 1 into 4. So, I will write 1 into 4. Fine. Plus this one 2 into 5. So I will write 2 into 5. Fine. Next plus, sorry, this is a plus symbol. 3 into 6. So we will write 3 into 6. So 4 plus 10 plus 18. So 14 plus 18. So the value result is 32. Fine. Let me show you. Okay. Clear? So this is the way dot product is done. Fine. Now here it is showing transpose of 2D matrix. We have already learned transpose means the row will become the columns, the column will become the rows. Let's do it. Okay. So if I transpose 1, 2, 3, you tell me the answer. Okay. 4, 5, 6. And now I will transpose the matrix. Transpose symbol is given by this way. So what will happen? Simple. No worries. This one will come this side. This is the row becomes the column. So first I will write 1, 2, 3. Nothing to be confused. This one will become downwards. Second row, this one will start from the second column. So 4, 5, 6. Clear? So what happened? See, this is the column that has become a row. This is the row that has become a column. Okay, no confusion. Just take this one, put it in this way. Second one, put in this way. Third one, put it in this way. Okay, the matrix will be transposed. Let me show you. This is the original matrix. This is the transposed matrix. 1, 2, 3, 4, 5, 6. Clear? Okay, now the next one is determinant of a matrix. Now how to get the determinant? Let me show you. 4, 7, 2, 6. Like 4, 7, 2, 6. This is our matrix. Now the rule is that you have to, let me show you why this way first. A, B, C, D. Now determinant of matrix means this one will be multiplied. So A into D minus this one will be multiplied. B into C. Okay. So AD minus BC. Fine. This is what is the determinant. So here 4 into 6, 24 minus 7 into 2, that is 14. So what is the value? The value is 10. You get how to get the value of determinant of a matrix? So the value will be 10. Let me show you. Fine. Now tell me one thing. If you get something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then how will you do the determinant? Simple rule. First you take this one. When you take this one, then you just simply don't consider this one and this one. Just forget about them. Okay. Now the same rule. This one multiplied by this one minus this one multiplied by this one. So I will write 1 into, be very careful, 5 into 9. So I will write 5 into 9. Fine. Minus 6 into 8. So now it will become 6 into 8. Done. Plus. Now, now I will consider 2. I will take this one, 2. So what you have to do, just delete this one. Delete it. Fine. Let me write first 1 and then there was 4. Now I will take 2. So I will write here 2 into. Now what will happen? Just corresponding column and rows will be deleted. Forget about them. What is left? 4. So 4 into 9. See here. 4 into 9 minus 6, 7. So 6 into 7. Fine. Done. Now plus. Now let me erase this one. Okay. Now take this one. 3. So I'll write 3. Now delete the corresponding rows and columns. Corresponding rows and columns. Forget about them. So what is left? 4, 5, 7, 8. So 4 into 8. So I will write 4 into 8 minus 5 into 7. So minus 5 into 7. Now simply calculate the whole thing. So you will get the determinant of 3D matrix. It's simple. Whatever the dimension is, you have to just delete the corresponding rows and columns and calculate the part. Okay. So here you can see this is the determinant of the matrix. Now you can do one thing. You just calculate this one, write this one here and check whether you are able to solve this or not. Okay, but in while doing the machine learning project, you don't have to calculate all these things this way. Okay, you just have to write the functions. But you should know what is happening in the background, like how it is calculated. Otherwise, you will not be able to think something of your own, right? But the fact is that you don't have to calculate because calculation is done by the function, and for everything a function is written over here. All we have to do is that we have to use them while they are required. Okay, so you can see that this is such a strong library and we can do so many things by using Python. Okay, so as of now, what we have done, we have just imported it, created an array, different kinds of array, linearly spaced by generating random values by 1, by zeros. We have seen what are the dimensions of an array, how can we resave, how to join arrays by row wise or column wise. Okay, and what are the operations we can perform like addition, sum, different kind of statistical operations. We have done what is a dot product, how to transpose any array. Okay, and we have also seen that how to get the determinant of a matrix. So we have done many things, but a lot to do. See, I have also written a blog here where everything is written in an organized manner, and we are going to learn all these things. Next class, we will start generating random values. You can refer to this blog. This is completely free, available on Medium. You just can click the link and see all these things. Okay, so we have already done some part, and from our next class, we will do other things. Okay, bye. Happy learning. Hello everyone, welcome back to this channel. So today we will continue our last class, that is learning NumPy array. If you have not seen the previous video, please watch that first. Okay, let's start today's class. First, I want to generate some random values. So I want an array which will have 3 rows, 2 columns, and all the numbers will be randomly generated. Okay, now in that scenario, I have to use random.random function. And I have to provide the same. Then see, it will give me an array, 3 rows, 2 columns, and all the numbers are randomly generated. But suppose I want these numbers to follow standard normal distribution. There are different types of distribution, but this distribution, the standard normal distribution, means that it must have mean value of 0 and standard deviation of 1. Now simple same here, but the function is random.randn. Okay, now if I run this, again I will get some values which have mean 0 and standard deviation 1. That means these values are following standard normal distribution. When you will do machine learning project, you will come across where you may need this kind of arrays, so you can create by using these ready-made functions of NumPy. Fine. Now suppose I want some normal random integers, then what can I do? I have written say 2 comma 3, and now the function is random.randint. Randint means it will generate integer values but randomly. Okay, low limit, I have just provided some limits. Low limit means it will start from 1. High limit plus 1 because the last one is excluded. So I want it to be up to 10. And size means whatever I have provided, that I want 2 rows, 3 columns. Now let me run this one. See, these are all integers but randomly generated. And all of them following the rules. Low limit 1, high limit 10. See here. So within 1 to 10, all the numbers are randomly generated following the same. Okay, so you have learned three functions: random.random, random.randin, random.randin. Fine. Now let's understand some trigonometric functions we can do using NumPy. First, how we can convert an angle to radians. Let me show you first. Suppose I draw a circle. Consider this as a circle, please. Now, these are the radius. This is a radius, this is a radius, this radius. Now tell me, what is the angle value? That is 90 degree, or we can say this is pi by 2. What is the value for this one? Same, pi by 2. What is the value for the next one? Like this one, pi by 2. What is the value for this one? Pi by 2. So if I take this total one, what is the value? That is pi, because pi by 2 plus pi by 2, 180 degree. Now what is the value for this one? This one is also pi, that is 180 degree. So you can say that this is 90 degrees or pi by 2, total 180 degree, but the complete circle, this is pi plus pi, that is 2 pi. Fine. So now let's see this one. First, I want to calculate sine of 90 degree. Like I want to calculate sine value of 90 degree. Okay. Now you cannot directly put the degrees. Instead, you have to convert it into radians. And these are the radians value. Okay. Now suppose I write 180 degree. This is degree equals to pi. No doubt with that. You can see here this is 180 degree. So this is equals to pi, because 360 degree 2 pi, 180 degree pi. So I can write 90 degree equals to pi by 2. So I have converted the angle into radians. Now I want the value of sine of pi by 2. Okay. Now see how we can write this in NumPy. Here I have written angle in radians. You can write anything. Then I have written 90 degree. I want to calculate sine of 90 degree. First, I have to convert it into radians. So I have converted the 90 into radians. Here the radian value is stored. Now I have written the function np dot sine inside angle in radians, the radian value. Now if I calculate the sine value, see it will show me sine of 90. You know the value sine 90, that is 1. What is the value of sine 0? It's 0. See here, we will check. 0, it is converted in radian, np dot sine of radians, that means 0. So I can get the value of sine 0, that is 0 0.0. Clear? So you understand this one? This is the what happening in the background, and this is in a single line. You just calculate these things by using numpy array. Fine. Now value for inverse functions. You know inverse functions? Inverse functions mean, suppose I want sine inverse of which value I have taken here? 1. Okay, 1. 1 means 90 degree, we have just checked. So we want sine inverse of 1. How to calculate it mathematically? First we consider it as theta. We consider sine inverse equals to theta. So we can write sine of theta equals to 1. If it comes here, it will go this side. No issues. So we want the value of theta which is equals to 1. For which value of theta it is equals to 1? We have just seen also, but you should know also that this is 90 degree. So theta means simply 90 degree. Now if we convert it into radian, this will be pi by 2. Check, I told you here, this one 90 degree angle, pi by 2. So this is the radian value. Now suppose what is the value of pi? 3.14. We all know these things. Now divided by 2. So we can get 1.57. Fine. Let me run this one. See here I have taken 1. I want the value 1.57. Okay. So which function do you need to do these things? Arc sine. Simple, put the arc sine functions and give the value you want to know. Then it will give you the radian value. Fine, no issues with that. If you want to check with something else, 0, what will be the answer? Sine inverse of 0. Let me show you this one too. I want sine inverse of 0. That is what our question is. Now we consider that this is equals to theta. So we can write just simple sine theta equals to 0. So if sine theta equals to 0, that means which value of theta is equals to 0? That is 0. Simple. So let me run this one. The answer is 0. So by using this function, you can get the inverse also. Inverse of any. Simple. You put cos, you put tan, see the value, and then check whether it's working or not. It will work. These are simple single line NumPy functions. Fine. Now you can convert the angle to degrees. We have already learned how to do this. So you just put any value, then convert it into degree. Okay. Now see here, I put 0 here. That's why the value is in degree 0. If I give 1, then it will be 1.57. Here you can see that the value is in degree 90 degree. So sine 90 equals to 1. Fine. Now let's do the next part. That is some statistical functions also we can apply by using NumPy array. Here see, I have generated a random array. We have already learned that random.randint starting from 1 up to 100. Last one will be excluded and I want 10 as a size. Now let me show you. See here 10 numbers and randomly generated. Now if I want to calculate the median value of the array, I'll just write a function called median. It will give me the median value. Now how can I calculate percentile? Percentile if we want to calculate, I have to use this function. And if you want 25th percentile, 75th percentile, 50th percentile, 100th percentile, just by writing this function, you can get the percentile of the data set. For discovering the outliers, percentile will help you a lot. Okay. Now next, the last one, array comparison. I have taken two arrays, 1 to 3, 1 to 4. Now what I want to compare them. Just check whether they are equal by giving the equal function. Whether they are not equal by giving the not equal function. Greater, greater equal, less equal. Okay, simple use this function, pass these two array, and then if you try to print, it will show you the result. Let me show you. This is very, very simple. It will give you some boolean values, whether equal or not equal. Here just I have checked np dot equal array 1, array 2. So 1 1 equal, 2 2 equal, 3 4 not equal. That means true true false. Clear. Here you can check less equal. So 1 1, that will be false. Sorry, less than or equal. So 1 1, that is true because they are equal. 2 2 equal, 3 4, 3 less than 4, yes, true. So in every case this is true. The same way you just check for others also. So you can just simply check each element comparison using numpy array functions. Okay, so we have completed the basic things of numpy array, but there are many other functions. But if you understand the basic, then you will be able to apply others also. Okay, bye, happy learning.